Okay, YouTube, in this video we're going to look at solving radical equations, but we're going to take an approach that that has us writing our radicals as rational exponents. So let's recall that when you discuss, some, I guess we'll write x to the mth power nth root, we could say this is x to the m over n power, which is fascinating. It just means that we can rewrite a radical in an exponential notation. So when we look at number 8 here, or at least all of these, it says go solve the equation, check your solutions. You see that all of these have rational exponents here, but number 8, we could write this. Let me enable that there. We could rewrite this essentially as the cube root of 3x, equaling -3. So what I'm going to argue is that it's not worth our time to rewrite it in radical notation. If you have a rational exponent, what we're going to do is this. The same thing we did with radicals, which is isolate the stuff that's in the radicand. Now what I'm going to tell you is isolate the base of the exponent, because we know that all of this right here, this 3x, is really what's inside of our radicand up here. So what we're going to do is we're going to isolate that on one side of this equation, and we're going to do the same thing we've been doing, which is exponentiate both sides of this equation. So now, here's the interesting thing about it. I'm going to exponentiate. I'm going to have to write this by hand, sorry. Exponentiate both sides by the reciprocal power of the one given. So here's the idea. Sorry about the handwriting. If we were to raise both sides of this to the 3 over 1, or the 3, you could write 3. I'm going to write 3 on the right side. But on the left side here, you can see that our power to a power property, which says, when you raise a power to another power, you multiply the exponents. Anything times its reciprocal is 1. So the fabulous thing is 3x to the 1/3 to the 3 over 1 becomes 3x to the 1, or just 3x. I could write 3x to the 1. But the idea is that we wanted to get rid of this exponent here. So you could see also up here, if we were to exponentiate both sides to the 3rd, that makes natural sense that these things would cancel out right there. So we're doing the same thing here. On the right side, -3 to the 3rd power, that comes out to be a -27. If we solve this now by dividing by 3, then what we're going to end up with is this statement x equals negative, I suppose that'd be a -9. So let's go ahead and check this out. If we plug it back into the original statement here, we would get this. We would get 3 times -9, which is -27 to the 1/3. And we're claiming that that equals -3. And of course, the cube root of -27 is 1, or sorry, the cube root of -27 is -3. Let's go ahead and take a look at number 9 here. Now, the interesting thing is we isolate the radical on one side of the equation. This is equivalent to saying the square root of x plus 6 equaling x. And so what I want everybody to see here is essentially this. Since we treat it the same way, since I already have this isolated on the left-hand side, we're going to exponentiate both sides like we normally would with radical notation, except for we have this rational exponent notation. So x plus 6 to the 1/2, we can see that that is all by itself on the left-hand side. We're going to exponentiate both sides now to the 2 over 1. And so what we end up with is x plus 6 on the left side equaling just x squared on the right. And to make things a little bit easier, this is a polynomial equation. Let's go ahead and subtract the x and the 6 over to the other side. We get x squared minus x minus 6. And as far as solving this goes, well, I suppose we could do this by factoring. So I know that x minus 3 and x plus 2 multiply out to be this. And so our zeros, or our solutions, should purportedly be -2 and 3. So I want to check these out as well. Now, I'm actually going to take a little bit of room here. Let's go ahead and try to block this off. If we were to plug in a -2 right here, we would get -2 plus 6 to the 1/2 equals -2. And what I want everybody to see here is this. You get 4 to the 1/2 on the left equaling -2. And so the square root of 4 is 2, and 2 does not equal -2. So as I've mentioned in the past, we would say that this one right here is what we refer to as an extra solution. We give it a different name, honestly, but I'd said extra because that's what it is. It's an extra solution, but we refer to it as an extraneous solution. An extraneous solution is essentially any solution that works out algebraically, but when you put it back into the initial equation, it's actually not one of the solutions. So here's what I can tell you. The thing was, when we squared both sides, you made the right side of this an x squared. And because it's an x squared, because of the fundamental theorem of algebra, it says, well, then you've got to get 2 answers. But the idea was, in the beginning, there was only really one answer, and it's this 3. And I do want to show you this here. If you were to plug in the 3, you get 3 plus 6 to the 1/2. is equal to 3 on the right side, and of course the square root of 9 is equal to 3. So we say we get only one solution on this, and that's just the 3. So now taking a look at number 10. Number 10, very similar to number 8, very similar to number 9. We have the base of this exponent, in other words, the radicand by itself. And I would tell you that I would be the last person on the planet that would ever choose to write this as x plus 2 to the third, the fourth root of that equaling 8, and then try to solve it. What I would rather do is take what we have here, which is this x plus 2, of course, to the 3/4 equaling 8. And since we have the radical expression, or at least the rational exponent expression on the left side isolated, we're going to raise both sides to the 4/3 power. So interesting story is those 3/4 times 4/3 is 1. They cancel. So we get left with just x plus 2. And on the right side, we get 8 to the 4/3. Now, one thing I do want to say about this is that it is evaluatable. It's able to be evaluated. But I'm going to write it as 8 to the 1/3 to the 4th, because I know the cube root of 8. I just know that it's 2. So what I get here is this x plus 2 equals the cube root of 8, which is 2 to the 4th. And so in other words, I guess we get x plus 2 is equal to the 4th, 16. So x, does it equal 14? Oh, we're about to find out. So if I plug this back in here, 14 plus 2, suppose we get 16 to the 3/4 equals 8. And if I were to rewrite this here as 16 to the 1/4 and then put the 3 on the outside and say, do I get 8? Well, the fourth root of 16 is 2, and 2 cubed does indeed equal 8. So 14 is the solution. Cheers.